Let's take another look at writing expressions. So we have put a screenshot of the cheat sheet that you can use that's in your resource packet under each of the problems. So 8 less than a number. Couple things that we do here. First, we circle our numbers. We highlight the keyword that tells us the operation. And we underline the unknown. So defining a variable, a number is what we don't know, so I'm going to use n equals a number. Then writing our expression, we see less than, which means I'm going to look under here. I know it's somewhere under subtraction. I see it right here. So less than tells me subtraction. But the most important part is to remember that with subtraction, order matters. So 8 less than a number. You are subtracting 8 from something. What are we subtracting it from? A number. Number 2, Marshall ate 5 times as many M&Ms as Lily did. So I'm circling my number. I'm highlighting the word that tells me the operation. I see times, which under here tells me it is multiplication. And then 5 times as many M&Ms as Lily did. We don't know how many Lily did. That is our unknown. L equals amount Lily ate. So it's 5 times that unknown amount. 5 times we write just next to the variable. You don't need to put an X because that looks like an X, not a multiplication sign. You don't need to do parentheses. You can just do 5 right next to the variable L. Number 3, Anna is 3 years older than Katie. Circling my number. Highlighting the word or phrase that tells us the operation. Older than, I see here under addition. So that tells me it's an addition problem. And then Anna's 3 years older than who? Katie. We don't know Katie's age, so that's going to be our unknown. K equals Katie's age. So with addition, technically the order doesn't matter. You could do 3 plus K or K plus 3. But anytime we see older than, less than, it goes after. So we are adding 3 to something. What are we adding it to? We are adding it to Katie's age. All right, number 4, 14 less than a number. We're circling 14. We are highlighting less than, which I see here under subtraction. And a number. We don't know the number, that's our unknown, so n equals a number is our unknown. Remembering order is important for subtraction. So 14 less than, we're not doing 14 minus, we are subtracting 14 from something. What are we subtracting 14 from? We are subtracting it from that unknown number. All right, number 5, Ellen has seen 3 times as many movies as Mike has. So 3, I'm circling that number. I'm looking for the keyword that tells the operation. I see times, which is a multiplication problem. As many movies as Mike has. Well, we don't know how many Mike has, so I'm going to use M for my variable. M equals the movies Mike has seen. So times told us multiplication. We are doing 3 times our unknown variable M. I'm just going to write them next to each other, 3M. Remember, we don't do M3. You always do the number next to the variable when you're showing multiplication. Number 6, Jerry is 5 years younger than Tom. Circling 5. Highlighting the word or phrase that tells me the operation. Younger than, I see right here under subtraction. And then Tom, we don't know Tom, so I'm going to say T equals Tom's age. And I did a little curved T so it doesn't look like a plus. Younger than is like less than. Subtraction order is important. Whenever we see younger than, less than, shorter than, it goes after. So we are subtracting 5 from something. What are we subtracting it from? Tom's age. All right, number 7, the quotient of a number and 5. So I'm circling number and 25. I'm circling our number. I'm highlighting the word that tells us the operation. Quotient is seen here under division. And then our unknown, again, we don't know the number. So I'm going to say n equals a number. So for our expression, when we're doing division, a lot of people want to use the actual division sign, but we want to get away from that. So what we're going to do is we're writing it as a fraction, because a fraction means division in the order it's given, a number and 25. So a number first and 25 second. Let's try it again. Number 8, the quotient of a number and 12. So I'm circling 12. I'm highlighting the key word quotient. Tells me it's a division problem. Our unknown here is a number. So I'm going to say n equals a number. And then our expression, again, we want to get away from using the division sign, so we're writing it as a fraction in the order it was listed, a number and 12 on the bottom. Number 9, William is 7 years older than Kevin. Circling 7. Highlighting the key word or phrase, older than. I see under addition, older than. It's the opposite of younger than. And then our unknown, Kevin. We don't know Kevin's age. So I'm going to say K equals Kevin's age. So as I've said before, addition, the order does not matter, but we want to get in the habit of doing it kind of properly as it is written. So 7 years older than means we are adding 7 to something. What are we adding it to? We are adding it to Kevin's age. Number 10, Michelle is 6 years younger than Stephanie. Circling 6, highlighting our keyword or phrase, I see younger than. Younger than, I see under subtraction. So it tells me it is a subtraction problem. And then our unknown, Stephanie. We don't know how old Stephanie is. And S kind of looks like a 5, so I might just use X for this one. X equals Stephanie's age. So, remembering subtraction, order is important. It's not 6 minus Stephanie's age. It's 6 years younger than Stephanie. So we're subtracting 6 from something. What are we subtracting it from? Stephanie's age. And the last two. Number 11, Chris ran 3 times as many miles as Amy ran. So I'm circling my number. I'm highlighting the key word. I see times, which tells me multiplication. As many miles as Amy ran. So we don't know Amy. So I'm going to say A equals miles Amy ran. Again, when we show multiplication, we don't want to use X for multiplication because that looks like a variable. So we're doing 3 times the number of miles that Amy ran, so 3 times A, which is just 3A. And then last, the quotient of a number and 9. I'm circling my number. I'm highlighting the keyword quotient, which is division. And then our unknown is a number. So n equals a number. And as we said with division, we want to get rid of using the division sign. For both multiplying and dividing, we kind of get rid of that. So I'm using fraction in the order was given, a number and 9.